So now we can look at how quantum mechanics explains some of these properties that we've been looking at. Some of these things we've mentioned. The chemical properties of elements are periodic because the number of valence electrons is periodic. Right? You go across the main group elements, and there's one valence electron, two valence electrons, 3, 4, 5, 6, 7, 8, and you get to the next row and it repeats. Number of valence electrons have a lot to do with those similar properties. So quantum mechanics says those patterns repeat because the number of valence electrons and the type of orbitals that they occupy also repeat. So we'll look at a couple of different groups in the periodic table. The noble gases, group 8A. Well, these guys, except for helium, all have 8 valence electrons. And so, the S and P rooms are full. The valence shell is full. Helium is first floor, only holds 2 electrons, but it's also full, right? So they have that in common. So the noble gases are especially unreactive. They used to be called the inert gases because there were no known compounds of these elements. Now we do know that there are some. But atoms that have 8 valence electrons, or 2 for helium, are especially stable. So that quantum level is full and the overall energy of the electrons is lower. So they're more stable. In a separate analogy, I think of these as being like the cool kids in high school, and this is what everybody else wants to look like. 8 valence electrons. Alkali metals. They look like they're on the other side of the periodic table, but really this should kind of be a cone, right? And the noble gases are right next to the alkali metals. So the difference here is these guys have 1 extra electron compared to the noble gases. These elements are very reactive because they want to have 8 valence electrons like the noble gases, and they're so close. They just need to ditch 1 electron, that stupid scarf that mom made you wear to school, right? If you took that off, you'd look like the in crowd and you'd be really happy, right? So as soon as you turn the corner, off goes the scarf and you leave it in a bush and pick it up later, right? So these guys react by losing 1 electron, and then they become more stable because they have that noble gas configuration. So that is why they form +1 ions. We learned that the group 1 metals all form +1 ions. This is why they do that. The halogens. These are next to the noble gases on the other side. They have 1 electron less than the noble gases. They're also so close to that status that they want, right? They just need the nose ring that mom won't let them have, right? So you just need that one little thing and then I'd be cool, right? So these are very reactive. They tend to gain an electron, and when they gain that 1 electron, that nose ring, then they have the same electron configuration as the noble gases. They look like all the cool kids, right? So they form anions with a -1 charge. They gain 1 electron so they can have a noble gas electron configuration. So a lot of metals and nonmetals only form 1 ion, and it's because that ion gives them a noble gas electron configuration. Group 1, all +1. Group 2 are +2. Group 7 is -1. Group 6 is -2. Group 5 is -3. And so they're forming ions that have the same electron configuration as a noble gas. So this is a figure, and it's understandable, but they misnumbered these guys because hydrogen isn't shown here, and that's number 1. But so these guys are all +1, +2, -1, -2, -3. This one's +3. Those are all the main group ones. And you might say, well, what about this one? Well, if you had to use it, I would expect you to choose a -3 ion. What about carbon? Carbon would have to gain 4 electrons or lose 4 electrons. Either way is too much work. So carbon's a nerd, and carbon's just cool and comfortable with themselves, right? It's like, I'm just not going to fit in, so I'm going to own it. I'm just going to be myself. Right? So carbon doesn't make ions. So we form anions when we're gaining electrons. Most of these metals or nonmetals will gain enough electrons to have 8 valence electrons. So what we'll see is that the s and p orbitals of the valence shell get full. The s and p rooms of that particular floor in the hotel get full. And that's, a good situation. So looking at sulfur, here's sulfur as an atom, 1s2, 2s2, 2p6, 2s2, 3p4. It wants to have 3p6 because that's more stable or that's more cool, right, depending on how you want to think about it. So if sulfur gains 2 electrons, it can have 3p6, but then it has a 2 negative charge. Now its electron configuration is the same as argon. It has the same number of electrons as argon, and they're arranged in the same way. Does it become argon? No, because the number of protons didn't change. Your personness, your personality, who you are doesn't change when you change your clothes, right? So sulfur can look like argon from the outside, from its electrons, but it's still sulfur. Yes?
So why does sulfur go to argon and not neon? So that one of the noble gas goes.
That's a good question. So why does sulfur go to argon by gaining 2 electrons instead of going to neon? Because to get to neon, it would have to lose, it would have to lose 6 electrons. And gaining 2 is easier than losing 6. Okay.
So when we write it shorthand, we're looking for the noble gas that's before it.
Mm-hmm.
And when we're doing valence, we're looking for the one that's closest to it.
Right. Yeah. So the nonmetals are all going to look like the next noble gas above them because they're going to gain electrons.
Mm-hmm.
The alkali metals will look like the previous because they lose them. So cations in this group lose all their valence electrons. And so then they're now in, they've cleared out that top floor. You guys we don't like you, go away. Now we have the next floor, S and P rooms are full. We're happy about this. That process is always endothermic, though. We talk about these guys losing these electrons because they want to look like this. Well, that doesn't mean there isn't a cost. They don't just fly off. You have to pull them off. There's energy involved. But here's magnesium, the atom. It's got these 2 valence electrons. It's going to lose the valence electrons, and this will be its electron configuration. This is neon, and it did this because losing 2 electrons is easier than gaining 6. So they're going to, whatever the smallest change possible.